Hello class, in today's video we're going to be identifying outliers and drawing box plots with the outliers present. The learning intention of today's video is we're going to know how to determine the outliers of a given data set, and lastly we're going to be constructing box plots with those outliers present. Firstly, outliers are data values that differ significantly, meaning that they have an abnormal distance compared to the rest of a data set. So as you can see down below, I've got all the values represented by a dot plot as well as a box plot. So as you can see, we can clearly see that this value over here is significantly different compared to all the other values. So therefore we can say that this over here is the outlier in this case. Now, if we represented an outlier on a box plot, we could either do this by representing it by using a circle. Alternatively, we could also use a cross to represent all the outliers present in a given data set. So over here, as I said, on the right hand side, you could represent this by a circle, but over here, notice that you could either also represent this by a cross or an X as well. It's up to your preference. Sometimes we can actually identify outliers pretty readily in a data set. So in this case over here, if this was my data set over here, notice that most of the values are relatively small except for 75 and 85. These values over here are quite large in comparison to all the other data set. So in this case over here, I could easily identify that 75 as well as 85 are outliers, and the reason why that is because, as I said, these values are quite distant from the bulk of the data set. So most of the data set lies within this range over here. This value 75 and 85 lies outside of that range over there. So therefore, this can be considered to be an outlier. However, it can actually be quite hard for us to pinpoint what the outliers are if we're just estimating, or whether if we're just eyeballing in this case. So if you look down on the example down below, for instance, I don't know whether 7 over here is an outlier, whether 8 is an outlier, whether 9 is an outlier, or whether all of these three numbers are considered to be outliers. So because it's quite hard for us to pinpoint which values is an outlier in a given data set, we need a way for us to prove they are outliers mathematically. And the way that we actually determine whether something is considered to be an outlier is by finding the lower fence as well as the upper fence. So from this point onwards, I don't actually want anybody to be estimating or eyeballing what the outliers are. There is a way for us to calculate what the outliers are by first finding out the lower fence as well as the upper fence. So in this diagram over here, I've got a box plot, and what the lower fence and what the upper fence are, they are these imaginary numbers or imaginary lines that we put up in place that act as boundaries. And we generally never represent these lower fences or these upper fences on a box plot. But if I were to show you, this is what it looked like on the left hand side. So I'm represented by these dashed lines over here. So anything, for instance, that's above the upper fence, okay, these are considered to be outliers, and anything considered to be below the lower fence are also considered to be outliers. Similarly, on the right hand side over here, if anything below this is considered to be an outlier, anything above this is considered to be an outlier. So that's why this is represented as a cross, since it's an outlier in this case. So as I said, values that lie outside of this fence are considered to be outliers. So anything contained within side over here, then these follow the main trends of a given data set. The way that we actually calculate the lower fence and upper fence is given by the following formulas over here. So lower fence is calculated by getting what the Q1 values and then subtracting it by a bracket 1.5 times IQR, whereas the upper fence is calculated by getting your Q3 value and then adding it by 1.5 times IQR. It's really important that you guys actually included brackets when you're doing this. Otherwise, if you're not using brackets in your calculator, you will obtain a different answer. So after you calculate the lower fence, upper fence, what you need to do is you need to make sure that you are referring back to your data set to see whether there are any values that's lower than the lower fence and to see whether any values higher than the upper fence. Most students make the mistake by just calculating the lower fence and calculating the upper fence, but they haven't actually referred back to the data set to work out what the actual outliers are. So make sure you refer back as your last step to ensure that you can see if there are any outliers present. Let's now look at an example so you have a better understanding of how to calculate the lower fence and the upper fence so that you can identify the outliers present in a data set. So the example reads, draw a box plot for the following data set showing outliers if present. Now remember, in order for us to calculate outliers, we need to calculate the lower fence and upper fence, but those formulas requires you to know what the Q1, Q3, and IQR values beforehand. So in order to obtain those values, we must obtain our 5-figure summary. So we need to calculate the median first. So let's do that. And now for this particular example over here, since the numbers are already ordered, we can now just perform the crisscross method. So cross out the numbers from either ends of the data set and progressively make your way towards the center. So if you make your way towards the center, what you will actually realize is that there are two values at the center. So you have to find the midway point between these two values. So in this case over here, the value that's halfway between 2 and 3 is equal to 2.5. And remember that your median essentially separates the data into two equal halves, into the lower half and into the upper half. Since our median value lies right over here in the middle, therefore, this is what our lower half and upper half would be. Now that we've actually separated our data set into the lower half and the upper half, then we could actually find Q1, Q3 by finding the medians of those respective halves. So I'll just do the crossing out method again. And if you do this, you're going to get a Q1 value of 2 because the midway value between 2 and 2 is still 2. And do the exact same thing for the upper half. So cross out the numbers from either ends to find out your median for Q3 for the upper half. And if you do this, you're going to get a Q3 value of 4 since the midway value between 4 and 4 is still going to be equal to 4. So if you do this, this is what you put entering into your 5-figure summary table. And this is what you'll be drawing as your particular box plot. However, we haven't actually accounted for our outliers yet. So therefore, if you actually did draw this on your post test or on your CAT, then this would be incorrect because you didn't actually label or indicate whether outliers are present. Remember that if you do draw this particular box plot over here, your whiskers is pretty much masking or hiding your outliers. So we need to draw or represent a box plot or represent our outliers, sorry, with the circles or with the little crosses. So the way that we're supposed to do this is now we're going to be calculating our IQR so that we can calculate the lower fence and upper fence. So our IQR is Q3 minus Q1, and therefore it's going to be 4 subtract 2, which is going to equal to 2. Now we can find out what our lower fence is going to be. So now I just substitute the values in. I know that Q1 is equal to 2, so it's going to be 2 minus 1.5 times 2, which is the IQR, and that will give you a value of -1. And therefore, what we need to do next is we need to look at our data set over here to see, are there any values that are smaller or less than -1? In this case, there are none, so there are no data values or outliers that's below lower fence. Now we can calculate the upper fence. So the upper fence is calculated by going Q3 plus 1.5 times IQR. Substitute values in, you're going to get a value of 7. Next, after I've calculated the upper fence, I refer back to the data set to see whether there are any values above 7. In this case over here, there's only one value that's above. 7 in this case is still on the dot, so we're trying to find out values that's above. So only 11 is above. So therefore, since 11 is greater than the upper fence value, 11 is therefore classified and considered to be an outlier. So if you were to draw this, this is what it would look like if you were to represent your data set. Now notice that I have also included my imaginary lower fence and upper fence. You don't need to draw those lower fence or upper fence at all. So as long as you draw everything without these red dashes over here to indicate my lower fence, upper fence, then you should get full marks. Alright guys, it's time for you guys to check for your understanding. So I want you to please pause this video right now so that you can identify whether one of these following data are considered to be an outlier. So answer this on the right hand side of the Edpuzzle page. So just write down the letter in this case that corresponds to the number. So please pause this video, give yourself 5 minutes, and then compare your answers with mine afterwards. So in order to answer this question, what we need to do first is we need to calculate what the IQR value is. So our IQR value is going to be equal to 9 in this case. And now I can start calculating the lower fence and upper fence. So this is my equation, my formula to calculate lower fence. I just substitute values. I know that Q1 is equal to 3. So 3 minus 1.5 times 9. If you do this successfully, you're going to get an answer of -10.5. In this case over here, there's no values that's smaller than 10.5. So what I'll do now is calculate the upper fence. Calculate the upper fence. So in this case, if you do this correctly, you're going to get a value of 25.5. if a value is considered to be an outlier, it would be greater than 25.5. In this example over here, the only value that's greater than 25.5 is equal to 26. So D is the correct answer for this question. Give yourself 10 minutes to answer this question as well. So what this question is doing is pretty much summarizing all the understanding that you've gained throughout today's video, but also in previous lessons. So you're trying to find out the 5-figure summary, but also calculate the outliers by identifying the lower fence and upper fence. So give yourself 10 minutes and then we'll compare our answers together. Alright guys, so in order to answer this question, what I've already noticed is that this data set over here is not ordered, so we need to order it from smallest to largest. If you did this, this is what it will look like, and then what we'll do is calculate answer part A by finding out what the minimum and maximum value is going to be. In this case, it's quite easy that our smallest value is equal to 0, our highest value is equal to 36, so we've already answered part A. To answer part B, find a median, we just cross out the numbers from either ends and progressively make our way to the center. So this is what it would look like if you did this correctly. In this case, your median is going to equal to 24. For part C, you're trying to find out the lower quartile and upper quartile. So this is the lower half over here. So to find out the Q1, I'll just find out the median of the lower half. So therefore, in this case, your Q1 is going to equal to 19. This is your upper half, find the median of this. So if you did this, your median, your Q3 value, is equal to 26. Now that I've got these values, I can then find out what the IQR is going to be. So go 26, subtract 19. This will give you an answer of 7. And now that I've got my IQR, I can now calculate the lower fence as well as the upper fence. So if you did this correctly, you should get a value of 8.5. Upper fence is going to equal to 36.50. And now once I've got these lower fence and upper fence, I can now refer to the data to determine whether there are any outliers present. In this case over here, there are no, there is one value that's smaller than 8.5. In this case, that's 0. So therefore, 0 is considered to be an outlier. I'll see if whether are there any values above the 36.5. In this case, there are no values that are greater than 36.5. So only 0 is considered to be the outlier for this particular data set. And now for part H, provide a possible reason for why the outlier occurred. Now this is going to be an open-ended question. There's many answers to answer this, and for this case of here, the way that I'd answer this question is that the bus drivers took a strike day, meaning they didn't rock up to work, and because they didn't rock up to work at all, that's the reason why you saw no passengers at all. So this is a possible answer, but you might have another answer that might be correct. Please put your answers on the right hand side so I can actually compare to see whether they're legitimate or not. What I'd like you to do for the remainder of today's lesson is I want you to answer or finish off questions E and F from exercise 9C, which you've answered in the previous lesson. And once you've done that, then please finish off answering questions 3 as well as 6 from exercise 9C. And if you've done that, then I want you to also answer question 1 and question 2 from exercise 9D. And then there's also an exit ticket up here, which only contains 5 questions. So it's not going to take you too long. This is the end of today's video. Hopefully you guys found this video enjoyable as well as helpful. I'll see you guys again in the next video. Bye.